Here's a paper with a blunt cases. Your computer use agent doesn't have a seeing problem, it has a thinking problem. And the fix isn't a smarter version model. It's making the agent stop looking at the screen at all. Computer use agents, the kind that operate files, managers, spreadsheets, browsers, email, are usually improved by strengthening perception, better models for reading a screenshot and choosing where to click. But a screenshot is only a loosey rendering of what actually matters. The real program state underneath the file, the DOM, the application's backend, hide whether a cell holds a formula or a typed in number. Relevant rows can be scrolled off screen or hidden entirely on one step that's harmless. Over a long task, hundreds of dependent operations, those small misreads compound into a genuinely wrong final deliverable. Was a screenshot give no reliable signal that the final result was actually saved correctly, which is exactly the judgment a long task hinges on. StateAct is a code-first multi-agent harness. The main agent doesn't click around a screen, it reads and writes the task real files, databases, and DOM directly through persistent base, Python, and a file editor. It only hands a sub-goal to a dedicated GUI subagent when that subgoal is genuinely irreducibly visual. Dragging something on a canvas, dismissing a pop-up with no script path, and that happens on just 28 of the benchmark's 108 tasks, 1.1% of all main agent steps. The sharpest idea in the paper is what happens when the main agent says it's done. An independent finish gate spawns that never reads the agent's own account of what it did. It rereads the actual saved files, the actual calendar store, the actual spreadsheet formulas, completely blind to the agent's narration, so it can't be talked into agreeing with a false story. To survive hundreds of steps without losing track of the task, sub goals get delegated to fresh, disposable subagent with their own clean context. The running context gets auto compacted near its limit, and the task check lives outside the message history entirely, so it survives that compaction. They test on OS World 2.0, a long horizon desktop agent benchmark, 108 tasks across 10 capability labels, multi item state tracking, cross source reasoning, conflict disambiguation, and human in the loop tasks. Every configuration runs on the same backbone, Claude Opus 4.8, with the same 200 turn budget. So the harness itself is the only thing being varied. What they found on that identical backbone, swapping the standard computer use harness for StateAct lifts binary success from 20.6% to 26.9% and partial credit from 54.8% to 61.6% while cutting cost per task roughly ninefold from about $72 down to about 7.8. That 26.9% is the best publicly reported score on this benchmark, ahead of GPT 5.5 at 13%, while costing less than every stronger system on the board. The ablations show exactly why. Focus the main agent back onto a GUI based computer tool instead of state, and the partial score drops to 51.3%. Actually worse than the plain screenshot baseline, a bash only version with no GUI subagent, no verifier, and no context management only reaches 45.9%. So code access alone isn't the fix either, it's the full combination. And when they manually audited the 79 tasks, that wasn't perfect. The dominant failure mode wasn't perception at all, it was reasoning, wrong values, misread instructions, imprecise geometry. Accounting for 38 of the 79 cases, only 14 were misses that verifier plausibly should have caught. Fix what the agent sees and what it thinks becomes the bottleneck. The finish gate has a real ceiling. It reliably catches structural problems, a missing file, the wrong path, unsaved edits, but it can't whether a value is actually correct. If the agent rederives the same wrong answer from the same source under the same misreading, checking that source again just reproduces the mistake. Of the 76 non-perfect tasks that reaches the gate, it only caught 8 and let 68 wrong results through, mostly because those errors were reasoning mistakes no structural check could ever catch. The author called this an intrinsic limit. Without ground truth answers to check against, a general verifier can only police structure, not truth, and roughly a fifth of all tasks hit a wall no harness can fix. Audio, video, or real time interaction, the underlying model simply can't process regardless of how it's wrapped. That's the shape of it. The fix wasn't a smarter model, it was giving the same model the actual data instead of a photo of it. And almost everything left broken is reasoning, not seeing.
Thanks for watching.